Hi, I'm Chris. I'm going to be talking about what I'm going to call big pictures. It's a technique I used quite a lot when I was teaching, so I'm going to talk through how I used it, why I used it, and how I think it would help more people. So I'm just going to start by talking through this image and how I would have used it. So put a big image like this on the screen. I wouldn't do it as they walk in. They'd walk into some kind of retrieval starter, like retrieval roulette, to bring back some key knowledge that they might need for the lesson and to test that they've retained previous knowledge. And then I'd select an image like this on the screen, exactly like this. Try to remove any other visual clutter from the screen. There's no title, there's no date, there's no outcomes, there's no school badge, there's no colours, there's just one big image. So there's no split attention, it's clear to them, this is the important thing, this is what I want you to look at. And then I'd be quite clear that sometimes they'd be questioning, sometimes it would be, does anyone know what this is? Has anyone seen this before? Trying to tease out knowledge, trying to assess what students are bringing into the lesson. But a lot of the time it would be very explicit, very teacher-led, very, I'm going to tell you a story about this thing. So in this case, this is a solar power plant. So it's not a normal solar panel like you might see on a roof. It's thousands of mirrors that you can see in these arcs pointing towards the top of these towers, and you can see the sunlight glaring on the front tower. I think it's really important when you show a big image like this to try and get across a sense of scale to students. So you can see roads. So if you can see a road, you can see some cars. You can see these are single-story buildings. So that's how it's huge. You might wish to have done some research and have a note card or some paper with some facts if it's about the facts. So I could have looked up how many feet tall or how many meters tall this tower is. I could have looked up exactly how many mirrors there were. But this was mostly to get across, look at the scale of this when we're talking about renewable energy on a kind of scale to replace a coal power station like the one down the road that we may have spoken about earlier in a lesson or in previous learning. It's a big thing. It's not just a case of whacking 3 solar panels in the field. It's a huge thing. You could also use this image, or you could come back to this image when you're talking about specific heat capacity and what's in the top of that tower. Why are they heating up a block of salt or molten salt? Why isn't it just water? So you can get a lot out of this one image. You can talk about where it is and why it is where it is. But I think that's more powerful than just drawing a sketch or saying this is a thing that exists, trust me, or even looking at a tiny picture in a textbook this big and everyone's squinting at it trying to see it. I think nearly every classroom in the country has a big screen, has a big projector. Show them stuff. So another way you might use this technique would be to look at a diagram. So this is something that you could dual code from scratch. You could draw this diagram on the visualizer on a whiteboard, air quotes, because you're not dual coding, the students are dual coding, but you know what I mean by that technique. So you could draw this image from scratch, you could emphasize the key parts, you could explain it as you draw it, and I think there would be some advantages to drawing it from scratch in that it wouldn't just appear on the screen. You would start from the coal, then you would draw the boiler and the furnace, you would then draw the turbine, the steam, you'd then draw the generator, you'd then draw the transformer, you'd then talk about the condenser to recycle the water. So there would be some advantage to drawing it from scratch, but I think some teachers just really don't feel confident drawing from scratch, and whilst it's definitely something that I wish I'd spent more time on, I think it shouldn't be a barrier to students seeing clear diagrams. So you could either put this diagram up and you could gradually unveil parts of it, or you could just put the diagram up but really explicitly focus where the attention goes on key parts. Then this is another example. So still on this power generating topic, So this is the Three Gorges Dam in China. This was actually on the bottom of the first big scroll down on Google Images. So I'm always quite careful to select a big image, but also an image that shows a sense of scale. You want to make sure that the images are high resolution if possible, so that they get a nice clear picture. So don't just whack the first search term you think of and then find the first picture. I think it's really worth doing a little bit of extra time to get a better resource, and you'll probably save a lot of that time if you can get your presentations this stripped back, because you now don't have to have words flying over the top, have logos, worry about boxes being aligned. If all you've got to do is find one image, copy and paste it onto Google, onto your slide, and then make sure you've got the story in your head, you've saved a lot of faffing around, and you can spend that time finding a better image and getting better knowledge in your head. So the reason I like this image of the Three Gorges Dam is because it's got that sense of background in it. You can see that it's not just the dam, it's the reservoir behind it, it's the people that live right next to it. You can see cars, you can see houses. So again, you get the sense of scale that this thing's huge, which you don't just get if there's just one image from the side. This is the set of locks that go up and down the side so boats can travel. So again, this is taking this image from over here, and we're zooming right in, and you can see like this thing's huge. Like this is like a little crane. This is a house. This thing is huge, and this is what we're sometimes trying to get across in science, is trying to get across a sense of scale to students. I think a lot of students don't really get how big things are or how small things are when we're talking about small physics, biology, chemistry. They don't always understand microscopic, don't always understand huge things. They kind of think everything's on the same scale as the world around them that they normally see in their town or village. So I think it's really important to try and show these when you can. And then this is another way of looking at the same thing. So I'd use both. So this is aerial photos, so satellites in this case because of the scale. It's a before and after, or somewhat annoyingly, the after is at the top. So you can see this is the original path of the river through gorges. You can see towns and cities down here, and then you can see the dams here. You can see the reservoir flooding. You can see the extra. And if this is in a science lesson, you might not want to go into the fact they had to move people. You might not want to go into the flooding of cultural artifacts, but it's a relevant part of renewable energy, that kind of this idea to get across that burning coal's bad because it gives out CO2 and mining's bad, but actually renewable is not always free and easy and cheap. There's costs to that as well, both economic and society and cultural. So trying to get apart this idea, I think a lot of lessons that you might have seen on tests or textbooks would be tell them about all the things, or they find out about all the things from posters in a lesson, and then they go and do a debate. But how can they do a debate if they haven't got any knowledge? So if you talk them through a tricky circumstance with an unclear ethical answer, then they will be well equipped to then apply that reasoning and that method to another circumstance. So I'm calling this Teaching with Presentation, the Power of Pictures and Storytelling. So I think this came up for reading stuff online, talking on Twitter, talking to people on Twitter. PowerPoint's got a really bad rap in Twitter in teaching. So I wrote a blog about this on Chat Physics and on my page a few weeks ago, and I think this bad reputation is often well deserved. I don't want to get into specific attacks. I haven't got any screenshots of tweets. I've not got any screenshots of lessons I consider bad. I didn't want to get into that kind of detail and turn it into a real argument, because I don't think it needs to be that. But I think we've often heard, just grab something from test, the lessons on the shared drive. Real teachers don't use PowerPoint. PowerPoint's for trainees. And I see why all that stuff happens. There's a lot of bad stuff out there. There's a lot of generic, ugly, badly laid out lessons with lots of activities to keep kids busy, but not actually much thinking. And then I think it's common practice or even policy in a lot of places to cram slides full, like I said earlier, logos, outcomes, SMSC, all leading to split attention with kids not knowing where to look, and I think crucially reducing the effective size of the screen. If you've got to have outcomes and a logo and remember your bag, and you've got to write in blue, and you've got to have this title, and if you shrink the size of your screen, so now your image is this big instead of this big, and I think that makes it less powerful and less engaging and less interesting, and it removes some of the detail from it. So I think this is a big idea. I think this is always kind of subconsciously driven how I taught without really understanding the reason. So I think it's often discussed that we learn by narratives. So this is from Dr. Bill Wilkinson's blog, and he's got some links to the research in it. Human evolution tells us the most powerful way to learn is through oral narration of stories. Our brains have evolved over millions of years to learn engaging and interesting stories that are relevant to us. High quality teacher talk combines key information intertwined in an interesting and engaging narrative is likely to be one of the most powerful ways to impart new information. And that just resonated with me so much. And I think it made me look at how I used to teach, and I think I would recommend it. But I think it can be very difficult to stand in front of a class and spin a story completely from scratch, from a blank sheet of paper under a visualizer or from a blank whiteboard. So I think this can be a useful prop to help, but I think also a really useful way to develop the story and to make it deeper and more real and more relevant to the students. I think it can be really useful to show video, to show the best people, Attenborough or Richard Feynman talking about the thing that you want to be talking about. But I think there's a lot of times where a lot of the videos shown to kids in schools are really bad. And even if they're not bad, they're probably not what you wanted to actually say. They're just kind of roughly what you wanted to say. They're not, if you show a pre-recorded video, it's not going to be related to where they've just learned, what's next, how long they can pay attention for, the terminology you used for things that are referenced, the terminology you want to use for this topic. If you can just tell the story, you can tune and all that stuff and tailor it to fit your class. So I think this is kind of how I see it in my head. So if you've got the idea of we're going to introduce some new knowledge and we're going to then practice, so that might have, and then there will have been some retrieval of previous knowledge before probably. I kind of see it as dual coding on a visualizer or the whiteboard, and or some narrative, possibly supported by some big pictures together into modelling, sort of I do, we do, you do, and some SLOP, shared loads of practice, whether that be booklets or whether that be worksheets or whether that be you writing 20 questions on the board. And I think it comes back to this idea of core and hinterland. So where core is, as Adam Boxer says, the stuff I want students to remember, the stuff I want to go into their long-term memories and for them to be able to retrieve. And hinterland is how you frame it. It's the stories, it's the examples that you use to bring that core knowledge to life. So I think the big pictures are useful because it grounds the story in reality, whether that be a historical picture, whether that be a current global thing, whether that be a local picture. I think it makes it real, and it makes it clear that you're not telling a fairy tale, you're telling a real story that's happened. I think it really helps learn the core context because it's a natural way to weave this hinterland in. I think in science in particular, exam questions are often in contexts that if students have only ever seen the exam specification in kind of the very dry way it's written, any context they see in an exam is new. If you've shown them context, they're more likely to be able to apply it to a different one because they've already seen their knowledge in a context or two. So therefore a third or fourth is necessary. And you might just get lucky and you might guess a context that comes up in the exam. Bonus. I think if you can just put a big picture on the screen, it stops that thing that you've all probably just done of racing ahead. I bet nearly every person has read to the end of this slide, even though I'm only on the third out of 5 bullet points. So if you don't have text, it controls, you're in charge. You control the pace and the narrative. Yeah, that requires a level of behavior management that isn't required if you've just got a PowerPoint with everything on it and you can just stand there and go, right, do this, right, do this. And I think a lot of the times the PowerPoint is a crutch, and that's okay if that's what's needed in your setting. Fine, put every word on here. You can stand there and just go, read this, kids, now read this, kids, now read this, now. That's fine, but it's a bit of a shame. It's more work for you to make that PowerPoint or tweak it to your class because it will need to be different every time you deliver it. Whereas if you can sort of absorb these stories yourself or have brief notes, like I've got some notes here for this presentation, if you can absorb that, then your slide of big pictures will be the same, or maybe you skip some pictures for some classes, or you've got a harder option and an easier picture to understand, but generally less differentiation from class to class because you're doing that, not the PowerPoint adapting to each class. I think it's another example of getting powerful knowledge into kids. So this idea that we want to expose students to the best that's been thought and done. We want to show them the world, things that they wouldn't have otherwise seen. So not translating everything into Grand Theft Auto or football or examples that they would have come across all the time, but showing them their subject and the world around them and how those things are linked and how those things apply. And I've said about split attention enough in the diagram. And then I think just this idea of big pictures, but then this idea of having a PowerPoint of big pictures or a Prezi or this is Google Slides, whatever, but having them ready, selected, shared within schools, between schools, within a map would be a really powerful time saver. You can use the narrator notes to store the story or have it in a separate document. And I think learning that story confidently enough to deliver that story is great CPD. It does take time, but you're going to be better delivering the lesson and answering questions about the lesson if you know the stories and if you know the content. I think if we started the system from scratch, we'd want teachers to know stuff and to have the time to learn stuff before they taught it. It seems weird and backwards that in a lot of settings that's not okay because you've got a PowerPoint, so go mark those books or go do that intervention because you've already got the lesson because there's some slides you can click on the shared drive. That seems backwards to me. So it'd be great to get back to this. It creates a real collaborative culture if you had one per department and everyone put their stories in, and then you'd have this debate about what order do we put them in, and is this story better than this story, and who should see this story, and should every kid see this one? That would be great debate and discussion within a department. It means you could have this open, you could do them, because there's only a few slides per image, you could have a lesson, you could have a whole PowerPoint for a topic in one PowerPoint. So whenever I'm going to teach waves to GCSE age kids, I'm going to open my waves PowerPoint. I might not need it this lesson because this lesson might just be retrieval practice, me doing a thing on a visualizer or the board, and then them practicing in their booklets. So I might not need any of these slides. But then a kid might ask a question and I might go back 4 lessons and throw up a slide from 4 lessons ago and go, right, let's talk about this picture again. And I've got it and it's there, and I've not got to go and dig around the shared drive. I've not got to shuffle through folders. I'm not going on Google Images and hoping I find something and settling for the first picture, which might be blurry or might not be the right angle I want. So I think all this stuff would deepen and develop subject teaching. Wouldn't cost any more time than the current way, but would be time allocated differently. And I think having the PowerPoint of the big image supports teacher delivery compared to just having the booklet or just having the visualizer. I think it is again a bit of a crutch, but much less of a solid, rigid crutch than the lesson as the PowerPoint. I'm just going to quickly talk about how I would find an image. So I put some words in Google Images. If you hit tools here, then this says size and then change it to large, because if you're blowing a picture up, you need there to be lots of pixels. So when it gets blown up, it still looks good. And you can see you get a few different angles, but the image I chose right near the start is none of these because I kept scrolling down. These boxes, Google recommends other words that relate to these words. So that might help you. So if I wanted to show them where it was, I'd click the location box. And then that would give me map type things, and then I might go back. But I think the main thing is scroll around, dig around, chuck some more words in. If I wanted to see zoomed out, I might chuck some words in. If I wanted to see at night, I might chuck at night in. But play around with it. I see so many times where when I started out, you'd find a lesson on tests, or you'd find a lesson on the shared drive. You would go to do more research on the lesson, and it would be the first picture 90% of the time. And the first picture is not necessarily the best picture, it's just the first picture. So then, having said that, this is a bit of a blurry picture of a roller coaster, and I'd happily put this up in front of a class. I have done. I've used this exact image, and I'd say, sorry, this one's a bit blurry. I can show you another one, but this one's got the angle I want. So this one is here for a specific reason, and that's fine. So I think it's okay to show kids something that's less than perfect if it's perfect in another way, but just tell them. So this is a blurry picture of a roller coaster. This is the big one, a black ball. You might want to use your favourite roller coaster to bring a bit of your personality, to try and get the kids to engage if you think that's needed or helpful or useful. You might show them a local one, you might show them the biggest one in the world, but I'll pick this one. And I picked this one because I'm going to talk briefly about how you could use this at the start of a topic, or the end of a topic, or the middle of a topic. So we were talking about energy transfers in physics. Roller coasters are a great example because they get lifted to the top, they get let go, and they, as it sounds, they roll and coast the way around. There's no engine, there's no fuel, so there's no extra things going in to calculate. The energy in the car at that point at the top is all there is to get it all the way around back to the station. There's no new energy, and that makes the calculations clearer and easier. So this image is good because it shows nearly the whole track in one loop. So you start here, you get lifted up here, you get released, you roll down, up and down, turn around, up and down, back to the station. And that's why I like this image. So I'd share all that thinking of why I've chosen this image, what it's for. So if you're showing this right at the start, you'd say, you could use it as a question prompt. What is it? Why is it like this? What happens to the energy level in the car as it gets lifted? Great gravitational potential energy. You could talk about, is the car going to have more energy if there's more people sitting in the car, fewer people sitting in the car? You could lift up 4 textbooks and drop them and make a big noise. You could lift up one and drop it and make a little noise, and show that the heavier the mass, the more energy in it. And then when it's hurtling down and gets to the bottom, and that energy, that gravitational potential energy, gets transferred into kinetic energy, or energy in the kinetic store if there's any picky physicists listening. So you could use it just for that simple idea of introducing energy changes from one store to another, or from one type to another type in the old energy language. That's fine. That would be an interesting way of introducing it. But if that was all you were going to do, you could just draw a slide or talk about a slide. So then this image might be a distractor, you might decide. Depends on your class. But then you could talk about more things with this image than you could with a slide. So with a slide, you could talk about friction, but the friction here is much clearer and easier to see, because most of the kids, or a lot of the kids, or some of the kids, depending on your context, will have been on a roller coaster. But this is where I think it's, a lot of the time, it would be tempting to put the image up and use it to question, but you can, and I think should often just use it to tell an explicit story. So you could say, what happens here, why does this happen, or you could just put it up and just tell them. So the roller coaster, the car gets lifted up by the motor, which winches it to the top, and then this happens. It comes down, gravitational energy gets transferred into kinetic energy, gets transferred back into gravitation, that goes up, back into kinetic as it goes down, back, and it shuffles backwards and forwards. But when the car gets to the end, it only just gets into the station. It's going loads slower here, right at the end of the ride, than it is here at the bottom of the first stop. Why is that? I thought the energy just went backwards and forwards and it transferred. And the reason is, it's not perfect. So this idea of conservation of energy, it gets transferred into other things, into heat, through friction and sound, which ends up as heat. And you can tell this story, you can pick out the details, and you can pick the details out relevant to the previous ability and the knowledge of the group of kids in front of you. You could use the same image at A level and go into more detail. You could also just show this image at the end, and you could draw on some heights. You could guesstimate how high this hill is from looking at the height of a car or a lamppost, and you could say, right, if that's about 6 foot, then how high is this? And guess how many people are on it. So if it's going this much energy, it's going to be going this fast at the end, and you could test all those calculations. So you could use it to show how you can use physics to guesstimate things in the world, which again is a thing that comes up in exam questions. They make up weird questions that don't quite make sense. They make odd contexts up, and if they've done some of that, then great. But I think for me, this technique is not mantle of the expert. We're not pretending that we're roller coaster engineers. We're not pretending that they've been asked to design a theme park and can they do this and can they name it, can they draw a picture and can they colour it in. We're focusing on the physics still, but we're just adding a context and we're just showing it in the world they live in. So there's some different ways you could use it. And I think this is going to be an example of, I think it's good in some ways. So this is one of the NIST projects to try and measure the kilogram more precisely than it has previously. So until the last couple of years, a kilogram was defined as being the mass of a lump of platinum under a bell jar in a lab in Paris. And if you wanted to know that your kilogram was the same as that kilogram, you had to go and basically measure yours against theirs. And then if that one gets scratched, now the universe is lighter. So that's obviously not a perfect system of measurement, so they come up with this system. I think it's good because it shows them some real stuff. This is what a kilogram is, and I wouldn't show this to every class because some kids would just get distracted, but some kids would really engage in this and they'd see real cutting edge science that's happening that they might have read about or heard about, or they're definitely capable of understanding what's going on. But this has got too many details, too many labels. It's just going to confuse you. It confuses me. It's going to confuse them. I think it'd be better to show them this image, which again was a good scroll down Google to try and find. It shows them a real scientist working in a real lab. Maybe he's a bit stereotypical because he's wearing a white coat and he's got gloves on, but it shows real science happening. So I think the wonder of this is it shows it's a real thing. It's cool. It's shiny. It's all aluminium and it's all polished and it looks lovely. It looks really technical and clever, like a film prop. But the real good thing about this is you can go into as much detail as you want to go into. So you could just say, it's basically just a giant seesaw. There's a pivot here, it swings round and round like this. If this side's heavier, it gets pulled down. If this side's heavier, it gets pulled down. There's some devices up here to measure to make sure it's balanced. What they want to do is make sure that this lump of metal on one side is perfectly balanced to this electrical force on this side. And once they know that, they then know how much electricity causes this much mass. And then instead of defining a kilogram by a lump of stuff, they can define a kilogram by an amount of electricity. And that's a much more universal calculation that other people can replicate, whereas they can't replicate having a block of stuff. And you can go into as much of the little detail as you like, and you show them this real physics. I think the other really key example would be to show them the scale of things. So we talk about mining and about how bad mining is, or not necessarily bad, but how complicated and mining is to balance up, and you could start from this giant image and you can zoom right in, or you could start zoomed in and you can zoom right out. So this one's again slightly lower. Unfortunately, I should have gone back and picked a different image. And you can see this thing in the middle is a bucket wheel excavator, and it's the biggest machine on earth. It's like 10 stories high, and it just about moves around. It basically chops up all these open cast coal mines in Germany in this case. So you could either show them a photo of a car, show them a photo of one of these next to a car, show them this mine, and then go, whoa, mining's big. And then you plant that seed that, well, everything that we've got basically isn't made from a tree or a vegetable, it's mined. It's being dug up from the ground, like this, or similar to this somewhere. And I think just that 30 seconds of, look at this, this is huge. All this stuff we've got is mined. Okay, so why is recycling important then? So rather than just going, right, can we have a debate about recycling? Is it good or bad? Do you like it when you have to put the green bin out? You start this and then you've just grounded that discussion in reality. So I think there's a few different ways to use this technique. You could use it to introduce scale and scope like this. You could use it to introduce context, like the roller coaster, you could use this to introduce further studying your subject and your subject at the cutting edge, like with the photo in the science lab, this one. You could use it to show diagrams like I showed. You could use it to show the one right at the start where you're kind of showing a technique and showing this is actually what this thing looks like. It's not a tiny diagram this big in your textbook. This is what it looks like. So I just think that PowerPoint is really badly used a lot of the time in education, but it doesn't have to be. If we can all just strip it back and like one big clear image on a screen and empower teachers and enable teachers to just talk over one clear image, I think it's a really powerful technique that sits alongside all these other techniques. So you're modeling your SLOP, dual coding, drawing it from scratch. I think all these things fit together where we're using these big pictures to enhance lessons. If anyone's got any comments or questions, I'm always about. It's just Mr. Baker Physics. Thanks for paying attention.